Hello everybody, welcome back to another informative video. Today I wanted to make a video on how to use the ACSM metabolic energy cost equations. I used the energy cost equations in a previous video on how to estimate VO2 max. Go check that out definitely if you want to learn how to do that. But today I kind of wanted to make a specific video detailing both the walking and the running energy cost equation. Now, the energy cost equations are great because they can help us do two things. The first thing being they can help us basically know the VO2 of specific activities. In this video, we're going to be covering walking and running. There is another one based for cycle ergometry, and I think that's it. There might be one more, but for those ones, the ACSM has developed equations for doing that. So again, today we're going to look at both running and walking. And the other thing that it can do is allow us to kind of set a specific workload for a specific VO2. So for example, if I want to work somebody out at a VO2 of 40 milliliters per kilogram per minute, I can actually plug that in and do kind of the reverse of the equation, which I'm going to detail as we get into that. So the first two things I wanted to show you are just the basic energy cost equations itself without any numbers put into them, just to kind of explain what we're looking for and just a few slight differences between the walking and the running one. So for the walking one, I noted right here that when they refer to walking, this is going to be at a speed of roughly 1.8 to 3.7 miles per hour. Anything outside of that might be somewhat accurate, but it'll definitely be flawed compared to if you chose a speed in between these numbers I detailed right here. And for running, it'll be greater than 5 miles per hour, kind of the same parameters. If you notice, when we're going through this, we have both a horizontal cost of energy. This is going to be if you are going on a flat path. And then we also have a vertical cost of energy. This is going to be if we have any incline or if we have any grade during our work. So if you don't have an incline or grade, this will just be zero, meaning there'll be zero energy cost for going up. Because obviously it takes energy to go straight, but also it takes more energy if we're going up as well as going straight. So that's why we have that there. And then plus 3.5, this is basically how much oxygen you need to just live. So obviously when you're working out, you need that 3.5 milliliters of kilogram per minute of oxygen to live, in addition to the oxygen to propel you horizontally and vertical. So this is just at rest. And if you remember, this would be 3.5 milliliters per kilogram per minute or 1 MET. I detailed that as well in my what is a MET video. You can go check that out. And down here for the running, it's a very similar equation. Some of the numbers are flipped, so there's a 0.2 instead of a 0.1 times the speed, and there's a 0.9 instead of a 1.8 for the speed. So those are the only two major differences. The rest is actually pretty straightforward, and it's just plug in your information into your calculator, and you're pretty much good to go. One thing I did want to note is that the speed that we put in here and here for the horizontal and here for vertical, that is going to be in meters per minute. So if you are using miles per hour on your treadmill, which most, I believe most treadmills, at least in the US, would be in miles per hour. I don't know about UK and other countries. You'll need to actually convert miles per hour to meters per minute. And it's a really simple conversion. 1 mile per hour equals 26.8 meters per minute. So all you have to do is multiply however many miles per hour you have by 26.8. So if you have 3 miles per hour and you're using the walking energy cost equation, you'll just do 3 times 26.8. That will be your speed in meters per minute, and we'll go right here, right here, right here, or right here, depending on if you're using the walking and running one. Okie dokie. After we got that introduction, I'm going to have a quick example for you. So this is going to be how to find a VO2 from a given workload. So say we are walking on a treadmill at 3.5 miles per hour and we have an incline of 5%. Those are going to be the two variables that we can change on the treadmill. So the first thing we're going to do, as mentioned above, we're going to do 3.5 times 26.8, and that'll give us a speed of 93.8 meters per minute. So remember, we can't use miles per hour. We need that meters per minute, and that'll help us with our next portion. So the VO2, that's kind of what we're looking for, and then equal 0.1x times 93.8 plus 1.8 times 93.8 times 0.05. I want to kind of make note of this because that's something that's very important. When we're talking about 0.05, if we remember, this portion of the equation is the vertical portion, so that's where the incline comes in. And 5%, as we know, is a decimal, so don't put 5 in here. That'll greatly increase the answer and will throw your VO2 way off. So make sure it's a decimal. That's really important. If it's 10%, it's 0.1, 15%, 0.15, etc., etc., just going up. So all I did was take that 93.8 and plug it into this part of the speed equation, this part of the speed equation. This is the vertical, and then take that incline of 5% and plug it in here. This is the walking one that was given above, not the running equation. So remember, walking, running, a little bit different. And now all we're going to do is take those numbers, multiply them together, give you 9.38, 8.442, and then 3.5, add them all together. I rounded them up to the nearest, what is that, 10th? No. Yeah. 10th, 100th. Anyways, so that'll give you 21.32 milliliters per kilogram per minute of oxygen. So that means that at that given workload, that will be the VO2 that you're using. Alrighty, so another really cool thing you can do with these energy cost equations is to program a specific program a workload from a VO2. So it's going to be the opposite. This time we're going to be given the VO2 and we're going to need we're basically going to try to find the incline in this. You can do it with the speed as well, but I think it's a little easier just to work with inclines. So we chose 40 VO2. That's what we're going to program for. And then I chose a speed of 6 miles per hour. If we remember, with the running energy cost equation, it needs to be above 5 miles per hour. So what we're looking for here is the incline. What is the percentage of incline that we're going to need to work at 40 VO2 at 6 miles per hour? So when we're coming down here, you notice the VO2 that we were initially looking for, and the last one we put right here. So the VO2 we already have. And then from there, we're going to need to, again, turn that 6 miles per hour into meters per minute. You can go back in the video and watch it again. All you need to do is do 6 times 26.8, and that'll give us the 160.8 right here, 160.8 right here. And then the rest of the equation, that's just part of the running equation, that 0.2 right here for the horizontal, and the 0.9, that's for the vertical portion of it. You notice right here, I have a variable. That variable is A. I could have done X, but I just did. I'm using X as multiplication, so sorry if that confuses you. The X is for multiplication. That A, that's my variable I have here. The A is going to be the incline. That's what we're trying to solve for, okay? So when we move down again, we're going to first multiply these two together. That'll give us 32.16. We're going to multiply all this together. That'll give us 144.72A because the variable's attached to it. Then that 3.5, that's our resting VO2, remember, that needs to stay with. That's just coming along with us. And then what we're doing here, we need to get A by itself. So this is going to be kind of just some algebra, some basic algebra. So we're subtracting that 32.16 to bring it over here, because again, we're trying to get A by itself. So do minus 32.16, bring it over here, minus 3.5, bring it over here. That will give us 4.34 equals 144.72A. I just brought that down, okay? So we almost have A by itself. Then all you have to do next is divide 144.72 by itself. That'll cross that off. A is by itself. Bring it down here. And that will give us 4.34 then, divided by 144.72. That 4.34 is what happens when you subtract those two numbers from 40. And then once you do that, it'll basically give us 0.029 equals A. So 4.34 divided by 144.72, 0.29 equals A. I simply rounded that up just to have an incline of 0.03 or 3%. So just from doing that backtrack calculation, now we know that if we want to work at a VO2 of 40, miles per hour, we need to have an incline of 3%. And there you go. So I hope you enjoyed the video. I hope you found it informative. I tried to make it as clear and concise as I could. If you need help with any questions or just have any questions on the video itself, please leave a comment. Make sure to like and subscribe. And if you have any ideas for any informative videos that I can maybe help you with your exercise science related classes, please let me know. Thanks for watching again, and we'll see you in the next one.